Start Composer by clicking on its icon on the desktop. The first thing the user will see is the Startup Configuration view. Here we can select monitors on which we wish to display video outputs from the Composer system. On each monitor, there is an identification tag in the top left corner that shows which monitor it is and which graphic card it is connected to. Also, the resolution and numbering index of the video output device is displayed. In this configuration view, we see all connected monitors in numeric order, displayed with its index number. A click on the index here will flash the info tag on the connected monitor as well. This will make the identification of the monitors rather easy. Here in the index drop-down list, we can specify with what number each monitor will be listed in the system, or if we want to use this as an output at all. Let us now assign the number 1 to the monitor number 2 that I am flashing in our list. This means that the monitor we see now will be given the number 1 and function as output in the system. But we do not want to assign the number 1 for the number 2 output monitor to the display, since we will have the Composer editor on this device. Therefore, I assign the number 1 to the other external display. This monitor will naturally not appear on this training video. This output signal will be presented in another way. Another thing that we have to mention is the sync switches. When a monitor is marked with sync, the system will align its internal rendering frame rate to that monitor's refresh frequency. At this point, that is all we have to know about this function. Now we have set the output device, we can start the application. In order to do anything with the system, we have to create a new document. In Aximmetry, we call these documents compounds. We create a new compound by clicking on the New button. In order to see any output image in general, we have to add a module that outputs a video signal. In Aximmetry, we call them video sources. These can be many things in the system, such as a photographic image, video file, or live camera. There are also different algorithmic image generating modules available. Now, for our training purposes, we are using a simple video file here. In order to add a video playing module, we simply drag and drop the video file into the gray area of our compound. For this, we call the file browser to our help. We see our file selection panel on the left. It is worth mentioning here that we have so-called project folders, which serve as storage for files and subfolders dedicated to separate projects. Obviously, at the beginning, we do not have many project folders, but we can eventually use the folder here called Common. It contains a set of media files, effects, and textures for general purposes. We are now selecting items here. In the Common folder, we open the folder called Videos, and in this, we select the subfolder called MISC. Here we can find two general-purpose video files. We select the second one, which contains a video of a flowery meadow. We select and drag and drop this file onto the compound area like this. This will automatically create a video player module, which naturally contains the specific video we have just selected. We can see that this module has several input and setting options together with several output options. The settings of each input option can be found here on the Pin Values panel. We shall come back to this later and illustrate what can be done here. Let us now concentrate on the outputs instead. The output we are interested in now is a yellow output at the top right. Aximmetry always allocates yellow for video type signals and cables. Now we just grip on the yellow dot, keeping the left mouse button pressed, and draw a line by moving the mouse beyond the right side edge of the compound area. When releasing the mouse button, we are sending our video signal to the number 1 video output, the one we already have allocated in the Startup Configuration view, to our number 1 monitor. Since we cannot actually watch our external number 1 monitor in this tutorial, we will follow it in the small preview window here. I will now close the other small preview panels, not to disturb us later. Also, I will enlarge this preview panel like this, so that we can have a more convenient look. Also, I am closing the file browser in order to free up more space. There are different ways of doing this. I am showing this too. Either click on this double arrow at the right upper corner of the view, or find its own button here with the drawer icon, which facilitates an easy on-off function for the file browser view. Or, if we may accidentally close it with the X button on the top, making the icon disappear from the icon bar as well, do not worry. we can always click on the View menu on the toolbar and the File Browser option there to make the file browser visible again. We close it now to make our compound work area larger. So what can we do with that video file that we have cabled as output then? Aximmetry is housing different processing modules, so-called post-processing modules, which are characterized by having one or more video inputs and one video output. We can add such modules to our video file by making a right-click on the gray compound work area and selecting the Insert Module option, or just pressing the Insert key on the keyboard like this. I will most certainly use this key on the keyboard because it is the fastest. We make an insert module like this. The Insert Module panel here is divided into different categories, including the available module types. Among these, we are now selecting the video post-processing modules, and I am inserting now a very simple module type, the so-called blurrer. I am selecting this by double-clicking on it, and now the module is visible for us here. Now we have to lead our video signals through this module. This can be done like this. Dragging a cable from the video file output pin to the yellow input video pin on the blurrer module, and then dragging a cable from the blurrer module to the display output on the right. Now we see on the preview window that the video has become slightly blurred. Now I will increase the value of the blur, and we can see the change better. This is one way of doing it. The other way is more convenient. It is done by keeping the Ctrl key on the keyboard pressed, while dragging the blur module onto the yellow cable like this. We see that the cable turns white. We now release the mouse button. Since this module has two inputs, the system gives us a window to choose input and output. After selecting the video input and the out items, we click OK to close this window. The wiring is now complete. Previously, I have shown that each module has designated parameters that can be adjusted in a special window to the right. This blur module has a so-called radius parameter, for instance. This leads us to the explanation of how these switches and buttons can be set in order to adjust the processing of the signal. When we have numeric parameters, for instance the radius of the blur, then we have the following methods to adjust them. One method is to click on the box with the mouse. Keep the left button pressed and move the mouse up and down to set a value. In this case, the values are changing with small intervals, 1/100th of a unit. In the case that we do that while pressing the Shift simultaneously, then the intervals will be larger, 1/10th of a unit, and with Control pressed, the change of values will occur with whole units. Finally, when both the Shift and Control are pressed, the change of values will occur with 1/1000th of a unit. All these adjustments can be done without the mouse. When we click on the field, the up and down arrow keys will allow us to set the desired value by 1/100th of a unit. While pressing the Shift will change the value by 1/10th. The Control will change the value by whole units, and while pressing both the Shift and the Control, the value will change by 1/1000th of a unit. Let us try out some other post-processing modules. We have, for instance, the adjuster, which allows us to make simple color corrections. We drag this new module onto the wire in a similar fashion as mentioned before with the blurrer. Let us decrease the blur value slightly in order to see the preview image clearer. The adjuster module has well-known common parameters such as adjustment levels for brightness, contrast, hue, etc. Also, a very handy module is the placer, which allows the user to move the video signal horizontally and vertically. There are also functions for scaling horizontally, vertically, and for rotating the image as well. In our preview window at the bottom, we only see the final result after having applied all processing modules to our video file. But we may want to see the outcome during a work session, after each phase in this modulation chain. This can be performed quite simply by drawing the mouse cursor on a section of a cable while keeping the Control key pressed. This function will show us the actual video signal running in the particular section of the cable. In other words, we can see the video image after adjustments, placements, and blur modules separately. This not only applies to the cable, but to the yellow output and input pin on each module. It is worth saying a couple of words on terminology here. The different colorful dots on both input and output sides of the module boxes are called pin in the Aximmetry system. So these are the input pins and these are the output pins. When we select a module, we can adjust it on the right-hand side panel, that we also call Pin Values Editor or Property Editor. The values of the input pins, more precisely the constant values of the input pins. This means that when we set a certain value, for example a horizontal offset in the Pin Value Editor, that value will not change throughout the whole operation time. In this case, 0.7 will be used by the system. Now we see a couple of value options from the editor appearing as colorful input pins on the input sides of each module. The reason for this is to enable the module to receive inputs from a wide range of controlling tools for animation and/or automation purposes. For the animations, there are a variety of simple and more complex modules. Here we are going to demonstrate an easy one. It is called LFO, and it may sound familiar to some of you from the realm of synthesizers. This module generates a back-and-forth oscillating signal. We can watch the function of this module by drawing the mouse onto the out pin while pressing the control key on the keyboard. Of course, this is not a video sequence, but a continuously changing numeric value. Its function is to deliver signals of different waveforms so that we can control repeating cyclical movements in any processing modules. If I wire the LFO out pin into the horizontal scale input pin of the placer module, for instance, we will generate an open-close effect. And by also wiring it to the vertical scale, then we will get an increase-decrease effect on our output like this. Within the LFO module, we can set any intervals for the oscillation effect. The value oscillates between 0 and 1 by default. Now let's narrow this interval a bit to avoid those extra large movements of the image. Then we can add a similar LFO effect on the radius pin of the blur module. Let us set the max value between 0 and a higher value. We can now watch the cyclical changes in the second LFO effect too. Finally, in the placer module, let us reduce the frequency of the LFO, resulting in a slower motion of the image. Now let's save everything we have done so far. Select File in the toolbar and click on Save, or press Ctrl S. In this case, the Save Compound view will appear, which looks identical to the file browser view explained earlier. Let us create a new project for our experiments here by clicking on the right mouse button on the Projects window and select New Project. We add a new project name in the Create New Project view, for example, Practicing. We now have added this new project folder. We can now single-click on the Practicing folder and name the compound file Test1. So far, we have used some of the embedded, elementary post-processing modules to create a more complex signal management process. The system lets us store these kind of complex structures as new compounds, and as a result of that, these new compounds can be used subsequently the same way as our already existing elementary post-processing modules. If we now open the file browser and the Common Project folder, and in that we enter compounds and then the effects subfolder, we can see that it is already loaded with many complex processing modules, similar to the one we have just created. Let us select one, for instance, Cartoon Sketch. This effect will add a cartoon-like look and feel to the video content. We add this effect simply by drag and drop. If we now wire our original video through this effect, we can see how it changes it into a series of simple, handmade drawings. This cartoon module is basically a closed one and behaves like the elementary modules. Moreover, it is linked to the file it was originated from. We called these type of compounds linked compounds. This means that if the file the compound was created in changes, and the effects are changed there, then this effect here will change too. It keeps itself updated, so to say. But of course this effect has its own internal structure, and it can be edited too. We can open up the module by right-clicking on it and select Edit Compound in Place. Then we simply enter the module by double-clicking on it. We now see that it contains many other modules in a complex web of interactions. Of course, compounds can be nested within each other, so other subcompounds could be used within this one. To leave this compound view, we double-click on an empty area. When we are back, we can select the Revert in-place modifications in the right-click menu, because we have not changed anything. By this action, the module is again closed and behaves like any other elementary module. We see that this module too has its own parameters. We can, for instance, change the density of the drawing or the sketch effect itself. In the case that we want to replace this effect module with another complex one, we just either right-click and select Change Import Source and select another effect, or we can directly drag and drop the new effect from the file browser onto the existing box. It will make the change instantly to the new effect. This is also a cartoon effect, but with many more additional parameter options, giving you the tool to create effects more freely. We now set a value we are comfortable with and save it. Let us assume that we want to assemble a similar complex compound effect of our own. How to begin then? At first, we select those modules that we want to include into our own new compound. Then, with a right-click on one of the selected modules, choose the option Group Selection, or press Ctrl-G. This action will pack all the selected modules into one new module, while maintaining both the input and output channels. We can operate this new box the same way as our earlier ones. We can open and edit it by double-clicking on it. In the box itself, we can observe every module item ordered as it was before the grouping action. Now we want to make this new effect module more controllable from the outside as well. In other words, we do not want to stick to its constant parameters. In order to achieve this, we can make the pulsating frequency of the placer scaling effect, defined by the LFO effect, adjustable by wiring out its input frequency pin to the left-hand side edge of the compound working area like this. We grip the pin with the mouse and drag a cable beyond the left edge of the frame. We have two ways of doing this. One option is to drag slightly beyond the edge and release the mouse like this. Now the adjustable frequency value option will be created with a name automatically. The name of this input will be identical to the name of the input pin of the LFO module, in our case, frequency. Or we stop dragging the cable slightly outside the frame until we see 3 dots in the black field. When we release the mouse button here, the Expose Pin dialog becomes visible, giving us the option to rename the input pin value manually. Let's give the placer frequency name to its pin now. In case we choose to exit this compound, we now detect the new placer frequency input pin on our newly created complex effect module, which is also visible as a new function in the module's own pin value editor on the right. Here we can easily adjust the speed of the pulsation. Now let's go back again by opening the module. We can of course rename these pins anytime by using the rename function in the right mouse menu, like this. The operation when we wire pins either to the left or to the right frames in the aximmetry is called exposing. Let's now do the same thing with the frequency of the blur module and name it blur frequency. We see immediately that it has become adjustable. If I adjust the slider up, the blurring becomes more rapid. Eventually, if we want to test how the setting structure of one of our compounds looks like, then not only we can see that in the pin values or properties view when selecting the module, but we can also click on the beige field outside the compound working area to make its pin values visible. What can we do if we do not want our exposed parameters to appear as numeric values in the pin value view? We may want to set a more user-friendly variant, a slider for instance, that we can adjust by moving the mouse left and right freely. For this reason, there are a set of dashboard modules available to us in the system. These modules will make the parameter handling of compounds more efficient and user-friendly. Among these dashboard modules, we can now select the dash scalar one here. This is called scalar, mainly because in Aximmetry, we call the simple numeric parameters or control values scalars. This is in contrary to the vector value-based parameters that are also often used in the system. We shall come back to this in one of the following tutorial videos. If we cable out one of our pins, for instance the placer frequency, through the dash scalar, let's do that now, then it does nothing special with the signal. It just provides us with a slider, instead of a numeric value for setting the placer frequency option in the pin values panel. As default, the dash scalar gives us an interval between 0 and 1, but of course it is sometimes not appropriate. In our case, we would like to obtain much higher frequencies here. To achieve this, we have to use the minimum and maximum parameters for the dash scalar module. Let us set the maximum value to 10. In this case, we are able to adjust the frequency between 1 and 10. If we now set the maximum value, we can see how fast the image moves in the preview. Now we have created a complex effect for our new project compound. We may now give it a name. We can use the pin values editor to write its name, for example, oscillating, like this. Now, how do we go ahead if we decide to use this new effect module in other compounds or in other projects as an independent effect? Well, we right-click on the module box and select Save Compound and Link. We can save it freely, anywhere basically, but let us now save it into the practicing project, the same way as we did with our main compound. The system allocates automatically the name of the box as the name of the file. We can change this obviously now or anytime later. With that, we have created an independent oscillating compound. Two things have happened here. First, the content of the box was saved into the file. Second, it is linked now to the file, meaning that if the file is altered from outside, it will then alter the behavior of our main test1 compound also. In the case that we want to terminate the linking of the compound with the file, then we right-click and select the Unlink Compound option. We keep everything as it is in the inside of the box, but when altering the file it was previously linked to, it will not change its content here in this test1 compound. In a similar way, we can also reverse the packaging or grouping of the compound with selecting the Ungroup Compound option after right-clicking. We can now see how we get back the original wired module structure. Now I would like to go on and show some mixing options in Aximmetry. So far, we have watched post-processing modules that basically have only one input and one output port. But there are some other modules which have more input ports and mixes these inputs in some way. I wish to show you a couple of examples here. One of the most simple of them is the Switch Video module. In this box, you can cable in quite a lot of videos. Let us wire our oscillating video and the cartoon video into this Switch Video module like this. This Switch Video has a parameter called Selected. This parameter determines which one of the many inputs will go to its output. I am now exposing this input to the left side for more convenient access to it. Well, I forgot to mention that if we expose a pin in the top-level compound, then it will be presented in a separate so-called dashboard panel. This means that whatever other modules I may select, its pins will appear in the Pin Values panel, but the dashboard panel will remain unaffected by these module selections at all times. Here in the dashboard panel, all pins exposed in the top level will remain visible. From now on, the dashboard panel can be used to change the selected video. Let us take a look at another mixing module. Since we can only make sharp cuts with this Switch Video module between the pinned inputs, we may eventually need a tool for making soft cuts with fade effect between them. One solution is to bring in the new module and manually wire all cables to its exact former pin location again. This is a tedious method. Luckily, there is a better solution to this. We right-click on the Switch Video module and then select Change Module Type. In the displayed Insert Module view, we choose another one, for instance the Switch Video Smooth module. With this action, we change the module type while keeping the existing wiring. Wiring to pins with the same name and type will be retained. Our control ability through the selected parameter in the dashboard panel will also remain unchanged. The only difference will be the soft or smooth change between the processed images. Also, we have the ability to change the characteristics of the change. We can set a much slower transition, a 5-second transition for example. We see in the preview how slow it becomes. Also, we can change the type of the fading in the parameter called mode, from the default cross value to an out-in value. This mode means the one signal is fading out, and the other is fading in. Let us watch this with increased fade time as well. Fade out for one, and fade in for the other, like this. The third type of mixing method that I wanted to demonstrate here is called blending. For this task, we have a so-called blender module. Now let's wire the output signals of the two different videos into this blender module, and these videos will be mixed here in a certain way. We can stop at this point since I wish to show you a useful shortcut. We see how the wiring is done from the blurrer. A cable is drawn with the mouse from the out pin of that module to the next box. In the case when our connecting box is at a distance, may be far out in the left and we can only see its cable already drawn to the next connection. We can use this existing connecting cable and clone a new one for us and cable it to our Blender module. We do this by holding the Alt key down while pointing to the selected cable with the mouse and then draw the mouse to the desired in pin on our Blender module like this. We can repeat this step from the cartoon module, but wire it into another pin this time. Let us wire the whole Blender module into our Video 3 pin on the Switch Video Smooth module. Then I set the selection parameter to 3 in the dashboard panel. We now see the output of the Blender module. More precisely, we see only the number 2 input of the Blender module because we use normal blending mode in the pin values panel. Let us change this to something more exciting, for instance the one called exclusion. We now see how this blending mode mixes the two videos into one another. At this point, it is worth mentioning a useful technique related to changing the type of control button in the dashboard panel. We can see that the top selected pin of the Switch Video Smooth module is wired out to the left of the dashboard. Now we have a highly inconvenient control associated to it with only distinct numeric values. We have a solution to this as well. Let's open the Insert module panel. Search for -integer. We cannot use the -scalar module here because we do not have a continuous numeric value. On the contrary, we operate here with distinct whole numbers, 1, 2, 3, etc. Also, we cannot just simply drag this module on the cable since this cable is an integer type, light gray line, and the input pin of the -integer module is a scalar type. Unfortunately, we have to unwire the selected pin from the left and thereby terminating the exposure of the Switch Video Smooth module. We wire the out of the -integer into the top selected pin of the Switch module and wire the -module to the left edge. It gets the name in, but we rename it to Switch here to make things easier. After this step, we see that the preview image is lost. The reason for this is that the default value of the -integer out pin is 0. And if we send 0 or a higher number than 16 into a Switch module, then we get an empty image. We should not panic. This is a normal scenario. We set the maximum and minimum values on the -integer now. We have 3 video signals coming in here, so we set the minimum parameter to 1 and the maximum to 3, like this. When this is done, we can see how the new slider control button in the dashboard panel changes behavior. When it is set to the left, we see the video 1 output. When it is set in the middle, we see the video 2 signal, and when on the right, we see the video 3. And this concludes the explanation of basic functions of the composer. Obviously, there are many more post-processing, mixing, and graphical functions available in the system. These will be demonstrated in the following videos.